Now we would like to demonstrate the use of SerIoT Honeypot in intelligent transport systems environment. On the left hand side you see a terminal that is actually displaying the activity that is happening in the honeypot region, and also a lightweight anomaly detection module which is directly installed on the roadside unit. The honeypot exposes V2 exports and also listens on the 802.11p interface, and moreover the honeypot also registers with the SDN controller, informing that it is available to receive any traffic for further analysis. Whereas the lightweight anomaly detection module, which is on the roadside unit, is capable of detecting certain type of attacks such as message flooding attacks, which we will be demonstrating in this video. On the right side is the graphical interface of Wireshark, which is displaying the messages that are captured on the roadside unit. Especially these messages are the CAM protocol messages, which are broadcasted by passenger cars that are periodically broadcasting CAM protocol messages to the roadside unit and are being used by the roadside unit to perform various activities inside the ITS environment. Now let's take a deeper look into the content of these messages. As we see here, the messages are pretty long and consist of various elements. Firstly, they consist of the transmitter address, which is here the MAC address, which is used to identify the particular passenger car or the device, or we can also call them onboard units. And in this test video, we have used two different cars. So as you see, two different MAC addresses that are actually broadcasting CAM protocol messages, one message per second. And this is a kind of configuration, a feasible configuration or a realistic configuration that can be seen in real environments. As we go further into the message content, as we see that the message is also signed, which means the messages are integrity protected so that they are not vulnerable to man-in-the-middle modification attacks. If someone modifies these messages, this can be known by when reading the messages on the roadside unit. The messages also contain the station type. As we see here, in this case they are the passenger vehicle, the passenger type, passenger car. They also contain more detailed information about the vehicle itself, such as the vehicle speed, the vehicle direction, the width of the vehicle, the length of the vehicle, and in some cases it's also possible to obtain the location coordinates of the passenger car. And this information is collected by the roadside unit, and it performs various different activities and control the complete ITS environment. In such an environment, let's now investigate what actually happens if an attacker is introduced in such an environment. So on the left hand side, we have the attacker that is ready to inject malicious information into this ITS environment. But before that, the attacker actually captures the CAM protocol messages which are sent by the legitimate devices and tries to replay them by injecting certain type of malicious information into the CAM protocol message. Also note that the attacker is using a different MAC address than the one that is used by real devices. So as we see here, what happened is that the attacker is trying to flood CAM protocol messages into the ITS environment, but attacker is using 5 frame per second frequency, which means he's injecting 5 messages per second, which is not a realistic configuration, or it is different configuration, and such activity is actually being monitored by the lightweight anomaly detection module on the roadside unit. Such activities are actually flagged by the LAD module, and the particular MAC address is actually flagged red color, which is a malicious event. And now the traffic coming from this particular MAC address, or let's say this particular attacker, will be redirected to Honeypot for further analysis. As we see now, the LAD module in the RSU has actually detected probably this could have been a denial of service, and it would immediately inform the SDN controllers about such an attempt to perform a denial of service attack, and to also redirect the traffic to the honeypot. And now let's take a look what's happening in the honeypot region. So we would be switching to the Wireshark interface that is capturing the honeypot traffic. So this is the, on the left hand side you have the Wireshark interface for the honeypot, and on the right side you have the Wireshark interface for the roadside unit. So now let's compare the information in these two protocol messages, so the legitimate and the malicious information. The attacker actually is trying to flood, as you see here, the attacker is trying to inject a lot of CAM protocol messages with malicious information, and these messages are actually being recorded at the honeypot. And now while we are comparing, we can try to focus on some of the important elements, such as the MAC address itself, which is a different MAC address than one of the test cards that we have used. But in any case, the attacker can also use or replay the same MAC address. And as we see, the attacker also uses the same signature like the one that is used by a real passenger car, which means the attacker is trying to steal some of the cryptographic elements from real CAM protocol messages and try to re-inject them into the ITS environment. And as we go more deeper into the content of the CAM protocol messages, we see that the attacker has also modified the speed, the direction of the vehicle, and also various other parameters that can actually create an impact when these malicious CAM protocol messages are actually processed by the roadside unit. We have demonstrated the attack with one attacker, but it is completely feasible for an attacker to launch this on a big scale and completely create a denial of service attack towards the roadside unit. The advantages of honeypot here are actually twofolds. The first one is to deflect the traffic in real time so that the roadside unit is not flooded with such malicious messages. And the second one is to analyze the attacker activities and learn various attacking techniques and patterns that can actually help in creating new detection mechanisms that could be used in real time so that the attacks can be detected and prevented in the first place. This is how SerIoT Honeypot detects and prevents attacks in real time.